Hey everybody, welcome back, guys. This is going to be episode 3 or part 3 of our crossbow limb failure series we've been doing here in 2023. Today, we're going to dive down the rabbit hole of how the crossbow manufacturer themselves can be at fault for your crossbow limb failures. Just want to start by saying I do not work for the crossbow industry at all. There are a lot of details, there are a lot of numbers, a lot of specs, a lot of things that I wish I had access to, but I just don't. But these are some areas that in the industry that I do work in, consumer goods, design, manufacturing, all that kind of stuff that I think applies across the board. No matter what you're talking about, I think it applies to crossbows. And I think it's some things that can help you guys understand how a crossbow could potentially fail from a manufacturer issue. Let's dive into item number 1. Number 1 is pushing the limits of materials used. Now, we're talking crossbow limbs in this whole series in this video. For this particular item, though, you guys, I want you just kind of in the back of your head to just think every time I say limbs, because I'm just going to say limbs throughout this, this bucket, I want you to also put strings and cables in. And that's because, especially when we have like a catastrophic failure of a crossbow, it's hard to tell the root cause sometimes on whether a limb actually let go or whether the string let go and the limbs also broke, or a cable let go and the limbs and string also broke. There's a lot that can go into some of these failures. So for this particular one, pushing the limits of material, when I say limbs, think it also applies to strings and cables. So when people talk about pushing the limits of materials, a lot of times you're going to hear on forums, Facebook groups, or whatever, you're going to hear people talking about how much we stress the limbs, how much load we apply to them, how much they bend around, the riser, and how just wound up stuff is. So when we talk about stress, I think the easiest way to look at this is to look at a stress versus strain curve. Without getting into a whole bunch of details, I've got a curve up here on the screen. This is just a very generic stress versus strain curve. On this curve, there is a point, and it is called the yield strength of a material. That point is where the curve goes from this very nice linear, just consistent slope, if you will, to a lot of that curvature that you see. So the yield strength of a material is where elastic deformation turns into plastic deformation. So everything that is on the very nice linear consistent slope part, that is all elastic deformation. And what elastic deformation is that is where you can apply a load to a particular material, and when that load is removed, the material returns to 100% of its, we'll say, original state. Basically, all that deformation is reversible. It goes back to its original. Everything that is at beyond the yield strength or the yield point on that curve is where the deformation is irreversible. So if you apply a load, you pass the yield point and you remove that load, the material is no longer the same. If you want to say degradation occurred, damage, if you wanted to use that word, for this conversation, we can. But the yield strength of the limbs is something that I really wish I had access to from different manufacturers or different crossbow designs, because when we talk about how much stress we apply, what we're really asking a manufacturer is how close are you riding the line to that yield strength? Because that is what we want in a crossbow limb, right? We want to be able to load it, we want to be able to cock it, keep it cocked, and then when we fire the shot, have it return to 100% of its original mechanical properties. And again, you guys, this is a spec that I don't know, but when you look at this curve and you think about performance, the closer you ride that line, the closer you get to that yield strength, the more performance you're getting out of that particular material. So when we look at crossbows that are going up in speed, increased performance, it's hard to not believe that we are getting closer and closer and closer to that line. And ultimately, we want to be somewhere below that line where there's some safety factors built in. There's maybe a little, user error factor built in to where if we cock it too hard, or I don't know, anything like that, where we could potentially load that limb a little more. This is definitely, when we talk about stressing limbs, this is kind of the number that people are referencing, and how close are crossbow manufacturers to riding that line and going beyond the yield strength, getting into that plastic deformation region, which can ultimately lead to a limb failure. All right, item number 2 is the limb supplier themselves actually having issues. So most crossbow companies, they do not make their own limbs in-house. I don't know of, to my knowledge, any that actually does. They use some tier 2 supplier to make their limbs, whether it's here domestically or overseas, doesn't really matter. But the crossbow manufacturer, they are not fabricating their own limbs in-house. And there are some things that can obviously happen with that. I don't know 100% for certain if this is the case, but my assumption is that crossbow limb manufacturing, especially compression molded fiberglass, which is what a lot of crossbow limbs are, they're not all, but a lot of them are compression molded fiberglass, that is a manufacturing process that requires validation. A lot of times with processes that require validation, the only way to really know if that particular piece has been made correctly is to destroy it. Think of a really good example is welding. To know for certain if a weld is good or bad is to destroy it. Now, obviously, things that require us, things that we purchase that are welded, right? You can't destroy them and then put them back together. That defeats the whole purpose. So what we have to do is we have to validate the process of welding. We come up with a set of process parameters, and it's a window. You have a target and you have tolerance on both sides. So you have a window at which the particular welding method and the particular materials used can operate and give you a good weld. So you weld a whole bunch of stuff, you destroy them all, and you say, is this a good weld or a bad weld? And when you say yes, this set of parameters produces good welds every time for this particular joint, this particular materials, we now have a validated process. We are now confident that as long as we operate within this window, we're going to get good parts. My assumption is that that is also how compression molded fiberglass is made. A thing that can happen, and this is really not the fault of the actual crossbow manufacturer, can be a little bit more on the tier 2 supplier, the limb supplier, is losing that validated state. They could make changes within that processing window that the crossbow manufacturer doesn't know about. And item number 3, we'll kind of talk about some other stuff, but those changes could potentially trickle down to, that limb getting assembled on a crossbow, that crossbow going to you, and you blaming the crossbow manufacturer, when in reality, they had everything spec'd right. They worked with the supplier to do all of the validation work, all that kind of stuff, and that tier 2 supplier made a change. Another thing that can happen is different batches or different lots of raw materials going into that validated state. So you usually try to, within your processing window for something that requires validation, accommodate for different lots of material, the variation, the raw materials themselves. If you get something, the resin maybe, or the actual fibers themselves, that is different, slips through the cracks, you process it within that validated state, but really the validated state and that processing window doesn't accommodate that particular batch of material. Again, that can trickle down to you breaking a limb and it really being the tier 2 manufacturer's issue, not necessarily the crossbow manufacturer's issue. So I just want you to think about that. There's a lot that goes into building a crossbow. There are more parties than just the manufacturer who you're buying it from that can potentially lead to crossbow issues and supplier issues, especially the limb suppliers. That can be something that can lead to a broken limb. Item number 3 is the limb supplier as well as the crossbow manufacturer's quality inspection, both their process and their inspection frequency. So once the crossbow limb supplier has made a limb, they're going to do some type of inspection method. It could be destructive, it could be non-destructive. Obviously, destructive tests are not going to go to the manufacturer themselves, but I don't know what exactly they do, but they're going to do something to make sure they're producing good parts, and they're going to do it at some frequency that is, you know, legit for them being able to confidently say, yes, this box of limbs that we are sending this crossbow manufacturer are all good. When that crossbow manufacturer receives those limbs, they're going to do the same thing or something similar. They're going to do some type of inspection process, could be non-destructive, could be destructive, and they're going to do it at some type of frequency again. And really what this one boils down to is volume and money, to put it quite frankly. Crossbow manufacturers, they can build perfect crossbows. They really, really can. You just aren't going to pay for them. So depending on their volumes, depending on their price points, they got to figure out a balancing act both with their supplier as well as internally, their incoming inspection, what they're going to do to make sure crossbow limbs are good and how often they're going to do it, and to keep that inspection within a dollar amount that trickles down to a price point that you're willing to pay. So I mean, that's really what it comes down to. So obviously, like, changes in type of inspection or inspection frequency can lead to better or worse quality. If you do more inspections and do them more frequently, you're probably going to have higher quality products versus if you do different inspections and you do them less frequency. But it really boils down to how much the consumer, you and I, are willing to pay for that, because it does. It costs money to 100% inspect every part in an indestructive method, or to, destructively test 1 out of every 2 limbs. I mean, that takes a lot of time, that takes a lot of people, that takes a lot of money. That's all going to trickle down to the consumer, you and I. And we're not willing to pay for that, and the crossbow companies know that. So there's a balancing act here of how they inspect and how often they inspect, and changes in that and volumes at which they produce crossbows. Those can potentially ultimately lead to, a bad limb slipping through the cracks. And that is common no matter what product you are buying, because most of the time, unless you're really willing to pay premium price or you're getting something custom, doesn't matter what type of consumer good it is, that is common throughout any industry of manufacturing. Item number 3 is all about inspection, and depending on what a crossbow manufacturer does, volumes, inspection methods, frequency, all that kind of stuff, any changes to that can potentially lead to a bad limb slipping through the cracks and getting onto your crossbow. Item number 4. This is something that I think is overlooked when it comes to limb failures, because ultimately, if there's an issue here, your limb is going to fail, but the limb itself potentially, it could have been totally fine. And what I'm talking about here for item number 4 is the limb pocket. So if you have any type of issue within your limb pocket, it could cause a limb failure. And some issues that you might have, I mean, it could be, I doubt it's just straight up design, but it could be a design or geometry issue where just the limb pocket in the riser itself and how it houses those limbs, it could just be bad. Another thing, it could be an assembly issue, so that your limbs are held in place somehow into that limb pocket by a fastener. Could be a fastener with a bracket. Whether that was assembled correctly, whether it was maybe over torqued or under torqued, those type of things, with how that limb sits in that limb pocket, those could potentially lead to a limb issue. coating or surface finish with inside that limb pocket. That is another one. So a lot of limbs are either like powder coat or e-coat, or I don't know, there's probably a bunch of different other types of coatings, but whether or not that coating and that surface finish is good, and whether or not it leaves little bumps, little things that can create stress risers inside that limb pocket, that could be an area where the limb pocket could contribute to a limb failure. And honestly, just the riser or limb pocket manufacturing method itself, kind of like the surface finish and leaving little bumps, little defects, that is also something. So, you know, machined riser versus a cast riser versus like a cast then machined post process riser, all those type of things where the limb pocket and the limb interface, a lot of times, I shouldn't say a lot of times, I think sometimes, I think a limb failure is actually induced by a bad limb pocket. So for example, let's say this limb or this crossbow that you have, it has some type of coating on it, and they coat the limb pocket and it leaves like a little bump. And I mentioned stress risers. So that little bump, when you seat the limb pocket in there, you torque it down and then you put a whole bunch of load on it. That little bump that's not supposed to be there can create a stress riser. It can create a concentration of stress within that limb that ultimately, you know, that limb and the crossbow's design was not intended to be there. That limb can break. You're going to see a limb failure. You're going to call your manufacturer and you know, complain about it, rightfully so. But the actual root cause was the limb pocket itself. So if you see a limb failure, if you have one and it's right around the area where the like limb and the pocket interface, basically where like the riser and limb pocket ends and your limb is just unsupported afterwards, if your crossbow limb fails in that area, I would highly recommend contact your manufacturer, telling them what happened, and requesting that you can send your whole bow back, because you want to make sure that that limb pocket is sound before you put another set of limbs on there, because the limbs may have been completely fine. It may have actually been a defect within the limb pocket itself. Item number 5. This one is kind of the human error element, and that is assembly issues. Now, I'm going to make the assumption that crossbows are predominantly manually assembled. They're assembled by humans, people like you and me, and not automated, not done by robots. I don't know that for a fact, but that is the assumption that I am making. And with that, you know, you can potentially have issues. So it could be work instructions were changed, how to assemble the crossbow itself, and maybe training was missed, maybe something wasn't clear, that kind of stuff that can lead to a potentially a limb failure. It could be the tools used to assemble the limbs, they changed, maybe they're out of calibration. That can lead to a failure. It could be the fixtures, if there are assembly fixtures used putting the crossbow together that changed, that maybe they're just worn or they're old, like that kind of stuff, that could lead to it. And ultimately, it could just be the human themselves who are assembling it. That if a person changes, if one person is assembling one day and another the next, maybe it's a experienced person versus a new person, that can all ultimately lead to what we're talking about, a crossbow limb failing, where in reality, the limb itself was fine. It was an assembly issue. Like a perfect example, at least to me, is kind of what we were talking about with the limb pocket stuff, is like the bolt that is securing the limbs into the limb pocket. Like if that is over torqued or under torqued, whether that is the person assembling its fault, whether that is a new tool, a tool out of calibration, maybe a fixture, all that kind of stuff. When I think about an area assembly related that could lead to a limb failure, that's kind of the first example that I think about. So this is just another potential avenue where if you have a limb issue, it may not be the limb itself, like the design, the materials, any of that kind of stuff. That could be totally fine. It could just be an error in the assembly process. And granted, all of the crossbow manufacturers, I don't care who it is, all of them are going to have a lot of steps in place to make sure assembly errors are minimal. Just like quality inspection and all that other kind of stuff, like they are going to have a lot of stuff in place to make sure work instructions are standardized, people are trained, equipment is calibrated, fixtures are, you know, validated or commonize, all that kind of stuff to reduce, I'm not going to say eliminate, but reduce as many of those assembly errors as possible. But if crossbows, which I assume are predominantly assembled by humans, there is potential that assembly errors could be the root cause to your limb issue.
All right, you guys, item number 6, it's the last one. This one's gonna be a little meaty too. I'm gonna do my best to explain it and not ramble, but I'm calling it just a tolerance stack up. So there are obviously a lot of components that go into building a crossbow, that go into a crossbow design, and ultimately there are a lot of things that could influence a crossbow limb failure. And when we talk about tolerances, or we talk about tolerance stack ups, what we're talking about is each individual component that goes into a crossbow. It has a nominal, it has a perfect part, number to it. But it also has, depending on how it's made, it also has a plus or minus tolerance at which that particular part can function as intended and still deliver the results it's designed to do. When you assemble the whole crossbow, you've got all these pieces with all this tolerance, and a stack up is where, in the best case scenario, your design can accommodate all of that tolerance, be it highs and lows, and still function as intended. That is a very difficult thing to do in complex systems like crossbows, like automobiles, like a lot of other stuff. And a lot of times engineers will use statistical methods, or they'll use other things. They'll use capability studies on particular parts, especially critical ones, to really understand if in the worst case scenarios, if my design can't function as intended, okay, where are these particular parts that are critical? Where are they actually running? Or, statistical methods will basically just give you some kind of a tool, if you want to call it that, to say, like, what are the chances that I actually receive a crossbow that is at the extreme highs or extreme lows of the tolerance that's all built into it. Why I'm telling you guys this is that it is possible that a crossbow is designed very well, that engineers did stack ups, that every component is spec'd accordingly to how it's supposed to function, as well as the tolerance that's allowed with how it's made, and that you could still potentially get, if you want to call it a lemon, or an outlier that just fails, because it is one of those statistical anomalies that falls outside of the range, and you got a crossbow that had all parts on the low end or all parts on the high end, or one half was high, one half was low, and that caused issues. That is possible. And I 100% think that the engineers and the companies that are behind designing crossbows, that they take this into account. But again, this goes back to volume and money, as far as what you as a consumer are willing to pay, and how many crossbows that a manufacturer has to produce, to how tight they can hold things. They can make, I said it before, they can make the perfect crossbow. I guarantee you they can. Between design, between manufacturing processes, between inspection methods, between all that kind of stuff, they can freaking make the perfect crossbow, but I guarantee you, will not pay for it, and they can't make enough of them. So there's a balancing act, just like with some of those other items that we talked about. Supplier controls and inspection method, it comes down to design as well, and the tolerances that can be accommodated within the design, and what we're willing to pay. There's trade-offs. You could potentially just get an outlier crossbow that breaks, and that literally is all that there is to it. All right, you guys, that is it. That is what I have for you. I really hope you enjoyed this video. I hope it wasn't too long. I hope it wasn't too technical. I hope I didn't ramble on too much, but I really wanted to do my best to kind of just put a list together of those 6 things of how a crossbow manufacturer can potentially be at fault for your crossbow limbs failing, your crossbow breaking, all that kind of stuff. And if you did like it, you want to see more stuff like this, please let me know down in the comments below. leave a comment. If there's something that I missed that you guys think is a key element to crossbow limb failures and how it ties back to manufacturer, also put that down in the comments below. Hit that like button if you like this video. You guys, will see you again on the next video here coming up soon. So thank you all for tuning in. I hope you enjoyed. Remember, be a sportsman, make a sportsman.